Hi, my name is Aravindan Chittapalam and my matrix number is CE200100. Okay, so for today's task, which is assignment 1, vision system, the task is given is to find in, intrinsic and also extrinsic. So, extrinsic means it's the parameter that define the location and orientation of the camera reference frame with respect to a known world reference. For the next part is intrinsic, the parameter necessary to link the pixel coordinates of an image point with the corresponding coordinate in the camera reference frame. Depends on the camera itself when estimated it can be reused. Okay, for this assignment we are given 8 times 6 checkerboard, 25 dimension for each square. So we need to take 10 picture, 10 checkerboard picture from our smartphone. Then we need to use any type of software such as MATLAB, Python, or anything else to find the camera calibration. So for this assignment, I'll be using MATLAB to get the camera calibration. So for the first part is we need to take 10 pictures. Uh, the checkerboard 10 pictures, which is 8 times 6. Next, we need to press MATLAB. So we go MATLAB and we press MATLAB. So I'll be using MATLAB R2021P. So this is the MATLAB. Okay. For the next part is we need to go to apps and go to the camera calibrator. If you don't have this app, then you need to download from add-ons. Okay, so next is if you go to apps, click camera calibration. Okay, so as you can see here, this is the camera calibration data browser. So for the first part is need to add the image that we take, which is 10 image of checkerboard. So you see, this is my image. So this is 10 image. So I'm using a smartphone which is Samsung 21 Plus. You need to open. Okay, so as you can see, we need to use 25 millimeter dimension for each square. So we need to take 25 millimeters, and the image is checkerboard. Okay, then the image distortion we can put as low. Then it will detect the 10 image. Okay, after it's done, as you can see here, it is detect points and checkpoint origin. So the stand image, then it will, the MATLAB will analyze and detected point and checkpoint origin. So for the next part is we need to calibrate. So you go here, click calibrate. So then it will show the reprojection error. Our overall error is 0.22 pixel. It's quite less. Then we get a pattern centric and camera centric. As you can see, pattern centric means it tells us which angle we take the picture from. I mean, which angle we take the checkerboard from. As you can see here, the stand angle I took the picture, so it shows. And for the camera centric is how is the image is taken from a straight line. You can see here. So if we see here, if we see from one way, you can see that how the image, the checkerboard image. For next part is we need to get the intrinsic and extrinsic value. So we need to generate MATLAB script. Okay. So then this is a MATLAB script. Then we need to run. So for when we press run, we need to save this file. So it's better to save this file in C. So save this file as Vision System Assignment 1. Okay, then it will run. Okay, so it will show the eccentric parameter visualization and the mean reproduction error per image. And then, as you can see in the command window, the value will pop up. So this is the value. The extrinsic consists of rotation vectors and translation vectors in millimeters. So this is the value. Then for the intrinsic, the focal length pixel, this is the value, the principal point pixel and radial distortion. So for this, then we need to publish it so that we can put in our report. Publish it. Okay, this will be the PDF of our report. As you can see, this is the value, intrinsic, and the mean probability projection error per image, and extrinsic. So that's all for me. Thank you.
Hi and Assalamualaikum. My name is Muhammad Amir Member Rofli. My street number CE200149. For the assignment, I use MATLAB to determine intrinsic, distortion, and extrinsic. So for the first, we go to the app and then we go to the image processing and computer vision and we choose camera calibrator. Okay, next we go to the add image. So this is my file for the image of checkerboard that I have captured that 10 image with different angle. So I use camera iPhone 11 Pro. And then the checkerboard square size 25 millimeters. And then we click OK. So we waiting for detect a checkerboard image. Is it error or not? Okay, there is a 10 image that detect. So for the green color is detect points, and then the yellow color is checkerboard origin. So 10 image on this MATLAB have different angle that I capture. Okay, after that we go to the calibrate. So after we calibrate and then have three pictures on MATLAB. So first, the reprojection error. So that this is a mean error in pixel that have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is for the image that I've captured. So and then we go to the pattern centric. This pattern centric is that angle that I capture the checkerboard. So this show that my camera snap the checkerboard. Okay, this is a camera centric. This is a plane visualization. So this have 10 different that I have captured on my phone. Okay, after that we go to the export camera parameters and then we go to the generate MATLAB script. And then we go to the publish. So we choose a camera calibration, that file that I have saved, that two part. So we waiting for the publish file. So this is a PDF camera calibration. So this have 10 image that I have captured. So we go to the standard error of estimate camera parameters. And first we go to the intrinsic. So intrinsic is a parameter that define the location and orientation of the camera. So we have the focal length pixel and principal point pixel and radial distortion. And then we go to the extrinsic. So extrinsic means that the parameter necessary to the link the parameters pixel coordinate and image point. So this is for the rotation vector, and then this is a translation vector millimeters. So this is a mean reprojection error per image that I have discussed before. So this is a 10 image that I have captured, and then this is for the extrinsic parameter visualization. So this is a plane. So this also have 10 image. Thank you.
Greetings to Doctor. My name is Puarsana Kiki Kanisan. My metric number is CE200184. Today I will be demonstrating about the assignment 1 task. So for this assignment, I'll be using the MATLAB software, and then the phone model that I have been used for this assignment is Acer Zenfone 3. So first we need to open the MATLAB and go to the apps. We need to find the camera calibrator. Here is it. And okay, here's the camera calibrator app, and we need to upload the images which I captured in the phone. So here I have saved the images at here. Let me upload it in the MATLAB. Okay, so we can see the image have been uploading. There are 10 images of the checkerboard from 10 different angles. So as you can see here, the result have been displayed. So the green color is the detected points, and the yellow color is the checkerboard origin. So, and it label the y-axis and x, and then the coordinates. So each images have its own details from image 1 until until the 10th image, which is the largest image. So let me proceed to the next step, which is calibrating the image. So it's now calibrating. Alright, as you can see here, there'll be reprojection errors and pattern centric. So once we gain the data, we can see the reprojected points, checkerboard origin, and detected points here at the image. So each time I click the image, it will change according to the image. So the details are here, and then we need to generate the MATLAB script. So before proceed to running it, we need to save the file first. So I'll be saving the file under the name Vision, and I'll save it at Vision assignment folder here. Okay, now the file has been saved. So let us proceed with the run. At part here we have got the results here. So the results are two figure. The the first figure is about the mean reprojection error per image, and the x-axis here shows the number of images, and then the y-axis shows the mean error in pixels. And for the figure 2, it is about the extrinsic parameters visualization in the three planes in millimeters x, y, and z. And at the common window, we also can check the focal length pixels, principal point pixels, and radial distortion, and etc. And we also can analyze the calibration of the images here. So that's all from me. Thank you.